This is a small James motorcycle dating around about the year 1950. I remember back in the early years the type of engine that was fitted to this bicycle was fitted to a 98cc Sun, which my father had given me. I tried to purchase one but wasn't able to obtain one, so I bought this little James and it had the same type of engine fitted. As you can see, it's nothing very special. It's quite basic. It's fitted with a Villiers 2F engine, and the name of that is basically because it is fitted with 2 gears. I remember the fuel consumption was something in and around about 100 miles per gallon. For people that use the metric system, this is a gallon measure. As you can see the word gallon on it. Approximately 4.5 litres. And what you actually done in these days, they had a nice little device here of, it's actually written on it, 4 measures of oil to 1 gallon of petrol. 4 of those, empty it in and give it a good shake. Now, I remember back in the 1950s, I worked in a garage, and wages were very, very small, approximately £1.10 a week, which today's money is £1.50. A gallon of petrol made a dent in your wages, and unable to get the oil. I remember using the oil in the garage. It was actually diesel engine oil, and this seemed to run perfectly well on it, and hence the fact that I had saved myself money. I don't have the back wheel to show you, as several bits were missing of this, and most of all parts were missing from the engine. If I can move over to the bench here, I can actually show you an engine complete that my grandson got for me in England. As you can see, it's a very simple device. Nothing to it. It's just about the simplest engine one could think of. Flywheel to provide the spark. Now, the engine that I obtained that was in the bike was in this state here. Bits missing. One half of the crankshaft. The other. As I say, the crankshaft is missing. These are the two gears, and they're operated through this little device here up in the handlebar, not unlike a 3-speed gear on a bicycle. No foot change. Now, the clutch, which contains one of the cogwheels, what is actually was missing on it is the selector, which sits into these things, slides along the shaft and engages with this. Hence the fact giving you your two gears. Primary chain down to the crankshaft. As I say, simple device. This is the contact breaker, which provides the spark for the engine, operated on this little cam here. By this flywheel. As you can see, this is not a complete circle, but has a hump on it. These are the magnetized weights, here, here and here, as you can see. Each one. As they pass over these coils, your spark comes out through here up to the spark plug there. Very simple. Now, to tell you a little story. On this little motorcycle, my cousin and I went everywhere on it, and he was over 6 feet tall. The result was, when we come to a very steep hill, we would move down into bottom gear, and the bike would get slower and slower until eventually, with his big long legs, he would step off, run behind me, and then when we got to the top of the hill, jump back on, and off we would go again. I always had a soft spot for Villiers engines, and set about finding out how I could get more speed from them. And I tried different various ways to try this out, and I discovered one of the more simple things was to improve upon the design of this. Here we have a crankcase of a 2-stroke engine, which is basically very small, unlike that of a 4-stroke engine where the mixture goes direct into the top of the cylinder. In a 2-stroke it doesn't. It goes into the crankcase. So before it is transferred, the mixture is transferred through these 2 ports called the transfer ports, and they come out further up the barrel. Now, in order to help the mixture get up into the top cylinder, you can see here the obstruction of this part of the barrel. So what I actually done was I removed that part of the barrel. Hacksaw, hacksaw, several cuts down, not only on that side, but on the other side. And then, when that was cut away, I beveled it slightly towards the transfer port. Then, as you can see, if I go back here, you can see the obstruction of the mixture coming here up through the ports. So in order to increase the compression in the crankcase, I tried another little dodge, and it was this. I took the crankcase and I drilled a couple of small holes, like so, and put in little short self-tapping screws. When I had that done, I mixed up ordinary isopon or body filler, and I tapered it up. I filled that area up till about there, so that there was sloped. If you can see this again, you would see that the mixture would come in here, would go up the slope, and this bit here was not obstructing the port. The next step was that when you're doing this, you would have to mount up the piston in order, because you're going to cut a section out of the piston also. It would have to be mounted on the crankshaft, which I can't show you, and I would like to go just to change a moment. You have to watch that the piston goes the right way round, because on a two-stroke engine there's a little peg there. The rings on a two-stroke engine are not allowed to turn. You've got two of them. There is the other little peg. The reason of these pegs is as the piston goes up and down the barrel, it uncovers these ports. In this case you have an inlet port, two transfer ports and an exhaust port. And if the rings were allowed to rotate on the piston, they would catch on the ports and break. So it's essential that when the piston is properly set up on the crankshaft, even though this is broke, don't pay any attention to that, let us assume the piston is in that position. The bit that I have cut of this barrel stayed down to about the base of it here. You mark along the base the same way, like so. You then take the piston. This will be done on both sides with the other half of the crankcase, so that basically you will have a piece cut out like that. On each side. Remember, this is for the transfer ports only. That will encourage the mixture of the thing. A word of warning here: do not touch the ports of the inlet unless you really know what you're doing, because if you try to alter the height of any of these ports, you'll upset the timing of the engine and you have destroyed the barrel. In the inlet ports, sometimes it may be permissible to move a small amount from the side, but never from the top and the bottom. Limited if you ever do that, because if you go too far, the rings could catch and break. So you're better just leaving the port, clean it out nicely, leave alone, polish it out. don't touch the exhaust port which is there. The only thing that you're going to do with the inlet port is when the piston is at the correct position, mark on both sides. Right? Now, that means that when you mark that with a sharp edge on the piston, it will show up here as possibly, you'll know that is the width. Now, you will notice this flat edge, right? You have to be very careful here. Going by these marks here, which is the width of the port, you will take a file and you will taper that edge back in towards the piston at maybe say a 45-degree angle. But do not touch this outside edge. Remove none from that. Only you're tapering that a wee bit on the inside and leave alone, because if you alter that, again you've destroyed the piston due to the timing. Now, the only other thing that is left to do is the cylinder head at the top. You might want to raise the compression a wee bit. So the cylinder head here, you take that off and you get a sheet of plate glass, smear it all over with grinding paste, and then lighten it down with very light engine oil. Smear it all out over the glass with a knife. Set the cylinder head on it and turn it in a rotary motion back and forwards, and even at times circular motion, keeping a firm pressure on the head. This will have the effect of raising the compression slightly in the top cylinder. You can really do nothing else. And one other little device I was going to say, in order to increase the compression in the crankcase, any space that you see here, right, any space that you see here is this space in here. You might like to get a little flat piece of alloy to fill up that space and set it in there, bearing on the outside edge so that it doesn't catch the inner edge. In other words, what you're trying to do is fill up that space. When you assemble the plate on, make sure it is properly sealed, because the compression can leak out here. At all times you want the compression here to force the mixture up through the transfer ports into the top cylinder, and you will find that your little motorcycle will be a lot more powerful if you do it right. There was another little tip that was tried at times, notably the exhaust. I'll come to that just in a second. Numerous things were tried. At the rear end of the silencer, which was normally maybe straight, there was a little cone on the back here, not unlike a little, I don't have one at present, a little filler, a little funnel tapering in, and it fitted over the end pipe, but it was clamped out off it so that the funnel was sitting out that way there. And this had the effect of when the air came in, it extracted the gases from the exhaust and then let it on out through the back. I think I have covered pretty much all about it. As I say, it's very simple. I've tried the motorcycle that I actually tried had a larger Villiers engine than that. It was, I think, if I remember correctly, it was a 6E or an 8E. If my memory's right, the 6E had a 3-speed gearbox and the 8E is a 4-speed gearbox. And I actually got this going really well for a wee Villiers engine. I can't really tell you much more other than the fact that when you do up these things, any power that you gain, you can lose a lot of it through the chain. Everybody takes a chain for granted. It's not. If you come around to the back wheel here, now we move to where the back wheel is. As you can see in the old motorcycles, they have this slot, which means that you can actually have the wheel not just maybe dead center, but when the sprocket is on the rear wheel for the chain, you can line this up by putting a straight edge across both ends of the sprocket, seeing that it touches at both ends, and also line that up with the sprocket on the engine and have it touching at the 4 ends. If it's not touching there, bring your wheel round a wee bit, because you will have a chain that tends to slightly run on the edge of the sprocket, hence the fact that it will give you a polished end on the chain. A power loss on a small motorcycle. The chain is very important. A worn chain will zap the power if it's not properly lined up, and you can always test the chain that it sits properly on the sprockets. If you bring the sprocket round and catch the chain halfway down, and if you can pull it out a sizable distance, it's worn. So remember, a chain is very important, as is brakes that are not binding, because all the little tuning bits you have done, you have actually lost it through a bad transmission. I can't really tell you any more about that, and I hope these ideas are of some help to you. As I say, I always had a soft spot for Villiers engines, and I've tried these out and got them to go really well.